Okay, hello everyone, and welcome once again to Communications 2. So we have modulations and coding techniques. Okay, for this week, the focus of discussion is on multiplexing. So we are going to learn three multiplexing methods. We have time division multiplexing, statistical time division multiplexing, and frequency division multiplexing. So let's start by identifying what is multiplexing. It comes from the Latin root plex, which means woven together or twisted together. So you have the word complex, which means many different parts are twisted together to make a thing complicated. So multiplexing in networking means multiple signals are combined together and thus travel simultaneously over one link. The purpose of multiplexing is about sharing. So let's start with time division multiplexing. TDM is transmitting different users' digital signals over one link by dividing time into slots or intervals and assigning them equally among these users. So we have time division multiplexing. Suppose there are three different users to send their data. At the transmission end, the multiplexer divides time into different segments, which we call time slots or intervals, and assign them equally. To look at the illustration, they can be sent simultaneously at the receiving end, then the demultiplexer separates them. The main feature of TDM is equality. Every user is allocated with the same amount of time, but equality is not efficient in many situations. Some users may have more data or a higher priority than others. Giving the same amount of time regardless of need or priority is not cost effective. That is why we need a new method known as statistical TDM or simply statistical multiplexing. Statistical multiplexing analyzes statistics related to the workload need or priority, and determines on the fly how much time each user should get. So let's take a look at the same example, but this time the user B has more data to send or has higher priority than both user A and user C. The multiplexer decides to give the user B most time slots and the least time slot to user A. Compared with the time division multiplexing, we can see the statistical multiplexing is more efficient and more in control. Next one, we have frequency division multiplexing or FDM, which is a different multiplexing technique. It deals with the analog signal. So FDM, let's take a look of this example. There are three different users sending their data over the same channel. FDM combines the signals together and then send them simultaneously as they travel separately in their own non-overlapping subchannels. In summary, FDM is about frequency channel and each user uses its own non-overlapping frequency channel. TDM is about time allocation. Every user is given with the same amount of time in TDM. Different amount of time in statistical multiplexing. But when do we use TDM and when do we use FDM? To answer this question, we need to know about baseband and broadband. Okay, there are two definitions of baseband in digital communication. So one baseband is related to digital signal transmission, where the entire bandwidth of the baseband system carries only one data signal at a time. In other words, every single signal would require an exclusive use of the shared medium. When I use the medium, no one else could be able to use it. They must wait their turn. So Ethernet is an example of baseband signal. Regardless of different names, whether it be Ethernet, fast Ethernet, 10 gigabit Ethernet, they all contain the word base. They are baseband. So baseband also refers to the original frequency range of the analog signal before it is modulated to a different frequency range. An audio signal may have a baseband range from 20 to 20,000 Hz. When it is transmitted in a radio frequency, it is modulated to a much higher frequency range. So now let's talk about broadband. It carries two or more different types of data in a separate channel. Broadband signals can share one medium at its peak, like a multiple-lane highway. Two or three vehicles can share the highway side by side at the same time. Broadband is also used as a marketing term for internet access. This meaning is only distantly related to its original technical meaning. In popular usage, broadband internet refers to any high-speed internet connection, such as what we know as DSL, cellular cable modem, or the satellite. However, broadband definition differs from country to country. In North Korea, the broadband may not be qualified as a broadband in USA. Baseband is related to what we know as the digital signal, while broadband is related to analog signals. Baseband system does not allow digital signals to share one medium simultaneously, while broadband system can transmit different data side by side at the same time. So let's take a look at this illustration of what is happening between FDM and TDM. So in FDM, we are sharing the channel at the same time, while in TDM, they are given allotted time to transmit the data, or the data, I mean. So that's it for this week about multiplexing, about time division, frequency division, and statistical multiplexing. So stay safe, everyone. Thank you, and God bless.